Hi guys, in this video we are going to perform a least squares regression on a data set containing the population of certain regions in Italy and the number of vehicles registered in that region. So we are going to try and fit a model to see the relationship between the total population in the region versus the association between the total population in the region and the number of vehicles registered in that region. So we are going to start off with commenting, and we're going to start off with the commenting that we are going to load the required libraries or packages, you can call them. We're going to need two libraries. So the first one is a read Excel that will help us read the XLSX file, and we are going to also need the pragma library. So we're going to run those two statements. Now we're going to load our data set. So row load XLSX data set, and we will name our data set vehicle data, and we'll use the read.xlsx function from the readxl package, and our file is named as vehicles italy.xlsx. We'll run that line. As you can see in our global environment, that vehicle data has been loaded. That contains 20 observations of 3 different variables. Let's have a look at our data set. So we're going to do vehicle data. If we run that, so as you can see that our vehicle has 3 different columns. The first one is the name of the region. The second column is the registration, and the number of registered vehicles, that is. And the third one is the total population in the region. The next step we're going to do is we're going to get a summary. Uh, Make sure you comment on every step what you're doing. So we're going to write get summary of data set. So run the function summary on our data set, that is vehicle data. We'll run that. So as you can see, that summary returns some statistics. So the first one is the region, that is len 20, and it is a character variable. The second is registration. The min is 145,263, and there are some calculations there. The third column is population. There's mean, max, median, first quartile, mean, and the third quartile. Okay, so the next thing we are going to do is we are going to calculate the slope of the least squares regression model using registration, number of registered vehicles as response variable, and population as the explanatory variable. So we'll write them down. We will calculate slope of the least squares regression model using registration as the response variable, and the uh, and population as the explanatory variable. Now the way we're going to do that is we're going to separate the two x and y. So first we're going to get the y. Y is going to be vehicle dollar registrations, and x is going to be our explanatory variable, that is going to be vehicle dollar so vehicle data dollar population, and then we're going to calculate the slope using a function called mldivide, and we're going to pass in x and y to that function. That will calculate the slope of the least squares regression model. Let's run all those, and um, let's look at our alpha variable. So that's going to be, the slope is going to be 0.601072. At this point, we can say that our model looks something like this. So it's going to be the number of vehicle registrations is going to be equal to 0.6061072 times the total population. There you go. So this is our, according to the slope we got, this is our model. This is how the model looks like right now. Now we're going to see the association between the number of registered vehicles and population. So we are going to plot a scatter plot, and add regression line. That is this line that we just said. Number of registered vehicles is going to be equals to 0.6061072 times population. That's our regression line. Now let's first plot the graph, so x and y, and we'll add our AB line. So A is going to be 0 because we have no intercept at this moment, and B is going to be alpha. So we can run those two lines, and as you can see that in our graph, we can see that there's a very strong positive relationship between number of vehicle registrations and the population. As the population increases, which is on the x-axis, the number of vehicles registered also increases. Okay, now the next thing we're going to do is we are going to try and see how good our model fit our data set. So we're going to do a residual analysis. The way we do it is we're going to get the residual plot first. So we will get vehicle reg fit first. That is we'll get fitted values of our number of vehicles registered using our model, using this equation. So we're going to multiply population by our alpha value. Okay, so we're going to do C of alpha times x. That's going to give us the fitted values. And then we're going to calculate the residuals. Residual is just going to be y minus the fitted y values. That is the vehicle reg fit. Okay, so run those. There you go. So that should give you the residual values. Now we're going to plot the residual values. So we're going to do residual, and let's do LWD equals to 2. And we'll add an AB line in the middle, and I'll explain why. A equals to 0 and B equals to is also going to be 0, and we will do LWD equals to 2. Let's run those two lines. And so as you can see in a residual plot, we plotted a line in the middle. That is to ensure that in order for our model to be a good model that fit well to our data set, we need to make sure that we don't have any patterns in the residual plot. So we need to ensure that the residual plot seems random, uh, uh, randomly scattered. The residual seems randomly scattered around the line in the middle of the plot, around the line that goes horizontally, the AB line that you can see here. So from our data set, we can ensure that we can confirm that our residual is in fact random. It does not follow any pattern there. Um, what I can also do is we can also plot a stem and leaf diagram to further confirm that our residuals are not following any patterns. So we're going to do a stem and leaf diagram of residuals. And the way we do it was we plot a function stem and we pass the residuals to it. Stem residual, and as you can see that most of the residuals are start with the number 0. So 0, 1, 0, 1, 0, 2. So those are all like 1, 2, 3, 3, and then 5, 6. So those are all close to 0. And below 0, there's 4 numbers. So that's negative 21, negative 20, negative 14, negative 12. And above 0, there is 4 numbers. So this is pretty symmetric and does not follow any pattern. So that's good. Okay. Now, so that's kind of like the visual representation or visually uh, making sure that our model fit our data set well, properly fit our data set, that our model properly fit our data set. Now, another thing we can do in order to see how good our model is, how good our model fit is, we can calculate the coefficient of determination. So we're going to calculate the coefficient of determination. And the way we do it is we're going to name it RSQ1. And then 1 minus sum of the y minus y minus vehicle reg fit. So y minus fitted y, that's going to be squared. That's divided by the sum of y minus the mean of y. Again, that's also going to be squared. And we want to see the values, so we're going to put brackets around it, parentheses around it. And as you can see that our value, our coefficient of determination is 0.9934617. That means that 99% of the variation in our number of vehicles registered is explained by the population. So that is because this is very close to 1, this is a very, very good model. Now, having said that, let's try and improve our model. So we are going to try and improve our model. So improve model by including an intercept. So we're going to try and include an intercept in our model. If you remember that we had no intercept, alpha is just a slope. So in our model, in your least squares regression model, there is no intercept. Now let's try and add an intercept there and see if that improves our results. So the way we do it is that we are going to add a column of ones to our x. So we're going to do x and 1. And then we're going to calculate the next alpha, our values, the slope and the intercept. So we're going to run the ML divide again. Again, we're going to pass in the new x and y. Let's run those. Okay, and let's put parentheses around it to see our values. Now you can see that that our slope is we have a slope added in here. So that's 1.202018 times e to the power negative 0.7, and our slope is here. So this is the intercept, and this is the slope there. Now let's get the fitted values using this new model. So get fitted values of y using the, let's say, improved model. We'll see if it's improved or not. Let's say using the new model rather than improved model. So we're going to name it vehicle reg 2, and we'll multiply x1 we're gonna do a matrix multiplication. So percent times percent. So percent times percent, and we'll multiply it by alpha underscore beta. That gives our fitted y values again. Now let's calculate the, we're going to compare the best fit line of the two models. So we are going to compare the best fit line of the two models. So we're going to plot the x and y again at first. X and y, and cx is going to be 0.8. LWD line width is going to be 6. We'll do that. We'll add an AB line using our previous models that had no intercept. So that's going to be alpha. And we'll give it a color to make sure it's different. And LWD line width is going to be 5. And we'll add another AB line using the intercept from the new model. So that is alpha underscore beta. Our intercept is the second row. And B is going to be alpha underscore beta. And it's going to be the first row. We'll give it LWD. It's going to be 5. And line type is going to be 3. Let's run all those. There you go. So that's the line without the intercept. Now let's plot the line with the intercept. So as you can see, the line without the intercept is the red line, and the line with the intercept is the dotted black line there. So as you can see, even with the intercept added, we don't see much improvement to our least squares regression model. In order to quantify if we in fact had any improvement using the intercept, introducing the intercept, we can try and calculate the coefficient of determination using the new model with the intercept. Okay, the way we'll do that is we're going to name it RSQ2. Again, it's going to be 1 minus sum of 1 minus, it's going to be vehicle regfit2 that uses our new model, and that's going to be squared divided by sum of y minus mean of y, and again that's going to be squared. Okay, so if we run that, we'll get a value. Now let's see if we had any improvement. So if we compare RSQ1 to RSQ2, remember RSQ1 is the coefficient of determination using the model with no intercept, and RSQ2 is the coefficient of determination using the model with the intercept. Let's see. So as you can see, RSQ1 and RSQ2 are both similar or equal, as a matter of fact. That tells me that introducing the intercept to our least squares regression model, to our initial least squares regression model, had no improvement in our model fit. So that's it for today. Thank you for watching my video. If you liked my video, please like and subscribe. And I will see you guys in the next video. Thank you.